If you put a fresh strawberry into the freezer and then let it sit on the counter for a while, you won't get a fresh berry back. You get a deflated, leaky puddle. This happens because of a basic rule of physics. Living things are mostly made of water, and when water turns into ice, it expands. Inside a microscopic space like a cell, that expanding water doesn't form smooth cubes. It forms sharp, jagged crystals. As those crystals grow, they act like tiny blades, physically piercing and ripping apart the delicate cell walls from the inside out. When the berry thaws, the damage is revealed. Those punctured cells can no longer hold their shape, so they leak their internal fluids, and the whole thing turns to mush. For almost every living creature on Earth, this microscopic shredding means that freezing solid is an automatic death sentence. In the far north, winter temperatures drop well below freezing and stay there for months. What's hiding in this frozen landscape is the North American wood frog. In the middle of winter, this frog is as solid as an ice cube. It has no brain activity, it isn't breathing, and its heart has stopped beating. About 70% of all the water inside the frog's body turns entirely into ice. Yet, unlike the strawberry, when the warm spring arrives, the frog simply thaws out and hops away completely unharmed. Now, this raises a massive biological mystery. How does this animal endure the exact same freezing process as the fruit, but skip the lethal cellular damage? The astonishing process actually begins the very second that environmental ice crystals first touch the frog's damp skin. This diagram shows the frog's immediate internal response. Its liver kicks into overdrive, breaking down its energy reserves to flood the bloodstream with massive amounts of sugar. This spike is so extreme that the frog's blood sugar levels reach 100 times normal. This thick syrup acts as a natural antifreeze. By flooding its veins with sugar, the fluid outside the cells changes chemistry. It pulls water out through osmosis. Now empty, the cells force freezing water to form jagged ice crystals safely in the gaps between tissues. The frog also builds up high levels of urea, a waste product that helps keep its internal proteins stable while they are frozen solid. By moving the ice to these empty spaces, the frog sacrifices its outer fluids to keep its vital internal architecture intact. This high sugar concentration also controls how the frog wakes up. Sugar lowers the melting point of ice. Because the frog puts the most sugar into its core, it thaws from the inside out, starting with the heart and the brain. As the core warms up, the heart restarts and begins pumping blood to the extremities. Finally, the frog takes its first breath. This precise distribution of antifreeze ensures a staged system reboot rather than a chaotic, damaging meltdown. In human medicine, doctors are fighting a desperate battle against those same jagged ice crystals. Currently, once a human organ is removed from a donor and placed in this cooler, it stays viable for only 4 to 6 hours. This creates a race against time. The short window limits how far an organ can travel, meaning a perfect match might be just out of reach because the flight is too long. Our current inability to freeze and store human tissue is the main bottleneck in transplant medicine, and it costs thousands of lives every year. Scientists are now directly copying the wood frog strategy in the lab to solve the storage problem. They are building synthetic cocktails using modified sugar molecules that look and act like the frog's natural antifreeze. These synthetic molecules shield human cells, completely preventing them from bursting, even when they are plunged into sub-zero temperatures. Using these frog-inspired methods, researchers have successfully frozen animal organs for days at a time, and then successfully transplanted them. This technology points to a future where donated organs can be shipped across continents, and transplants can be scheduled weeks in advance. This medical breakthrough began on the forest floor. The blueprint for preserving human organs was already there, hiding under the dead leaves of the freezing winter forest.